To get back to Oumuamua, if I know if it were to come back in our solar system, what would that mean exactly?
Well, it's interesting that you brought it up. We don't expect it to come back because its trajectory was shaped mainly by the sun's gravity.
Sure.
It was pushed by some non-gravitational force, which I
But if it
suggest.
did, that would definitely mean, right? Wouldn't that
Oh,
have to mean something?
oh yeah, that would mean that it has propulsion.
Right.
But we will have a better telescope to monitor the sky. It's called, I call it a dating app because it will allow us to date the next Oumuamua.
Oh, I like that.
So this dating app is the Vera Rubin Observatory in Chile that will start operations in a year. And it has a camera of 3.2 billion pixels. So 1,000 times more pixels than your cell phone camera. And
Holy
it will
cow.
survey the southern sky every 4 days. And surely, if there will be another Oumuamua, it will notice it. And we expect that to happen every year. So we will, most of the time, probably, most of the time, we will swipe to the left. But every now and then, we might find an exciting object. Yeah,
Find a
exactly.
match.
It's just like a dating event where, after the person left the room, you realize, I actually would like to know more about this person, but then you don't have the person's email address or phone number or anything. So rather than obsess with that person, you should date more and find someone similar. And that's what we could do with the next Oumuamua. And of course, my hope is we will get a close-up image of it, photograph, because that would be worth 66,000 words that I put into my book. I wouldn't write the book. Why would I waste my time talking about it if we can just look at an image? But in fact, we have the Webb telescope, which is 1 million miles away from Earth. And so if it observes the object and we observe it from the Earth, then it's as if you have two eyes and you can pinpoint the trajectory of the object in 3 dimensions very precisely, and that will tell us whether there is some internal propulsion, because we will be able to see exactly how it moves in 3 dimensions with a Webb telescope and a telescope on Earth. So I'm very much looking forward to the coming years. I think, we will know more. That's the way science is done, not by prejudice, not by the number of likes on Twitter. I should tell you, there was actually a poll yesterday of 1,000 people on Twitter. And it surprised me because the poll was, do you think Oumuamua was an iceberg, a comet, an asteroid, or a technological relic? And 51% of the respondents said a technological object. Wow. 20% said an asteroid, 10% said a comet, and then the rest an iceberg. So that was interesting, that people are so interested in the technological possibility. Of course, science is not decided by public opinion, but it shows you that people are really curious about it. And the way, that the pushback that is coming from the direction of the mainstream of scientists is just inadequate. We should be curious. If something looks strange, we should collect more evidence about it. And of course, it costs money. So we should spend that money and figure it out because the public cares about it.
It's literally the number one question I think that anyone that is ever born has. Are we alone in the universe? Like, why are we not trying to answer the biggest question that we have? It shows people's motivations. Like you said, they're just trying to flex, their academic muscles, if you will. Right. So, no, I get it. I would be just as frustrated as you.
I think part of it is, part of it is, if you look at politics, what you see is polarization. So both extremes do not make much sense, at least to me, because they don't, they are just believing in something without looking at the evidence, whether it supports what they are saying or not, on both sides. And the same apparently happens very often in science, because on the one side, you have the so-called experts. These are the scientists that have, base their reputation on past knowledge. and therefore resist any new knowledge. So they would say extraordinary claims require extraordinary evidence without seeking the evidence, so that they could be proven right without the evidence. It would always be correct to say that there is no evidence because they're not seeking it. That's all.
Yeah.
So they are right. By definition, they're right. They maintain their status as expert. Now, that doesn't make any sense to me. Sure. And on the other extreme, you have people who are believers. So they don't subscribe to the scientific method. They see a hole in the sky, and they would argue that's a wormhole. Okay? And I know some of these people. And that makes no sense, because we should learn from nature. We should collect evidence in the scientific way by instruments, not by eyewitness testimonies. If there is a hole in the clouds, it could be just a meteorological phenomenon. It has nothing to do with new physics. You should, if you have poor data, that doesn't imply new physics. It just means that your data is poor. Okay? And that's what many people don't understand, that, oh, I have poor data, there is some fuzz out there, some crappy data, maybe it implies new physics. Maybe, but to find new physics, you need exceptional data. You need exquisite data that beyond any reasonable doubt says standard physics cannot explain it. You know, physicists work for decades on trying to get high quality data to uncover new physics. Nobel Prizes are awarded for tiny variations in the physics as we know it, tiny. And therefore, you can't just have crappy data and say, oh, I think it's new physics. That doesn't hold water. So on the one hand, you have those believers that would say anything that is not understood is new physics based on crappy data. And then on the other side, you have the experts that do not want to collect the data. So you end up with a polarized situation that doesn't change over time. Why? Because no new data is obtained. The believers believe in it. They don't need the data. And the scientists say we don't have extraordinary data because they are not collecting it. And you end up with this stalemate. And that's exactly the situation that we were at regarding objects from other civilizations. And I'm trying to break that by getting the data. So the middle ground is not populated. This is a new path that we are carving. And it should be exciting because, like, just to give an example, in this summer 2023, we're planning an expedition to look for the relics from the first interstellar meteor that was roughly a meter in size and exploded 10 kilometers above the ocean level. Over
Papua
the
New Guinea, is that the Papua New Guinea?
Yeah, near Papua New Guinea, and we are. I received funding at $1.5 million from an individual that was excited about it, and will join us at the expedition. And we are going there to see if we can retrieve some of the fragments so that we can check whether it was a natural rock or some technological relic that is made of an artificial alloy. And that's the way to figure it out. And what do I see? I see some colleagues saying, that's a waste of time and money. Why do that? And, that to me, I think somehow they lost their childhood curiosity or their beginner's mind. It's really unfortunate. And that's why I enjoy working with young people.